In early 2021, inside a quiet facility in Peterborough, Ontario, a signature was placed on a contract that ended half a century of independent family control. The Russell family, the architects of Canadian solid-state power, officially sold Bryston Limited. For decades, the Bryston name had meant absolute permanence. Their amplifiers, heavy blocks of cast aluminum and oversized iron transformers, were bolted into the broadcast racks of the CBC, running 24 hours a day, 7 days a week, for 30 years without a single changed capacitor. They were the driving force in Canadian recording studios and the immovable centerpieces of basement rec rooms across the country. They were famously backed by a 20-year warranty, an unheard-of guarantee in consumer electronics. To buy a Bryston 4B power amplifier was to buy a machine that you would likely pass down to your children. This was a company that actively tried to destroy its own products before selling them, subjecting every amplifier to a punishing 100-hour burn-in process at the factory, just to force weak components to fail. If it survived Peterborough, it would survive anything. But that permanence created a paradox. How does a Canadian manufacturing company survive in a global audio market when its product is designed to never break and its customer is engineered to never need a replacement? A decade earlier, massive weight was the ultimate proof of quality. Now the market was shifting toward lightweight Class D digital amplification, streaming software, and imported convenience. But the real story of Bryston is not just the story of a 2021 ownership transfer. It is the story of a uniquely Canadian engineering culture that defied a disposable era. To understand why an industry built on planned obsolescence allowed a machine to last forever, one must travel back to a time when Canadian audio did not measure its success in software updates, but in pounds of solid iron. Every week, we explore the stories of Canadian speakers, amplifiers, and audio factories that shaped how the world heard music, and what happened when the global market shifted. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place. In Rexdale, Toronto, in 1962. In the early 1970s, the Canadian recording industry was expanding rapidly. In Toronto, facilities like Eastern Sound on Yorkville Avenue were tracking major artists, capturing the sound of a generation on thick, 2-inch magnetic tape. The physical environment of a high-end recording studio was a system of extreme pressure. Behind heavy acoustic doors, massive mixing consoles routed dozens of audio channels to passive studio monitors, speakers used in recording studios to reveal details clearly during mixing, mounted heavily on the walls or on reinforced steel stands. To make those large monitors push air into the room, a studio required an amplifier, an electronic device that increases a weak audio signal so it can drive speakers. At that time, the Canadian professional audio market faced a severe mechanical problem. The amplifiers available were either low-power consumer units that distorted when pushed or expensive heavy American imports. But even those premium imports struggled to survive the reality of a commercial studio. Modern rock and roll mixing demanded continuous, massive swings of electrical current. When engineers drove the monitors hard to check the bass response of a kick drum, the amplifiers would run out of voltage. They would begin clipping, a form of waveform distortion that occurs when an amplifier is asked to deliver more power than it can generate, sending a harsh, squared-off signal that routinely destroyed expensive tweeters. Worse, under the stress of 14-hour mixing sessions, these imported amplifiers would overheat. Thermal protection circuits would trip, shutting down the session, or internal components would simply melt. The smell of burning resistors was a familiar, expensive scent in Toronto control rooms. When an amplifier died, the music stopped. Time was money, and the market desperately needed a machine that refused to break. The solution did not come from a traditional hi-fi manufacturer. It came from a company that originally built blood analyzers. Bryston was founded in 1962 in Rexdale, a neighborhood in the northwest of Toronto, by Tony Harrison, John Russell, and Brian Russell. They were a precision manufacturing firm. By the late 1960s, John Russell had bought out his partners and moved the entire operation to Peterborough, Ontario. This industrial origin is the key to understanding the brand. Bryston was born in a culture of life-and-death medical precision, not subjective audio mysticism. In medical equipment, a circuit board does not have a warm tone or a musical feel. It either measures perfectly and works continuously, or it is fatally defective. John's son, Chris Russell, was an engineering student with a deep interest in audio reproduction. He looked at the heavy American amplifiers failing in Toronto studios and did not see a failure of art. He saw a basic math and thermal management problem. Amplifiers generate heat. If the power supply, the heavy iron transformer, and the large capacitors that store and deliver electrical energy is too small, the amplifier runs out of breath. If the heat sinks, metal fins on the exterior designed to pull heat away from electronic components are inadequate. The output devices literally cook themselves to death. In 1973, Chris Russell brought a prototype amplifier to his father. It was the blueprint for what would become the Bryston Pro 4B. It was not a beautiful consumer object. It was a heavy, utilitarian block of metal. It lacked the brushed silver elegance of Japanese hi-fi receivers or the glowing vacuum tubes of vintage domestic gear. The early prototype did not even have a proper top cover. It consisted of a massive, heavy iron transformer, oversized power capacitors, thick circuit boards, and a heavily anodized aluminum faceplate punched with standard holes so it could be bolted directly into a 19-inch broadcast rack. It was designed to do exactly one thing: take an electrical signal, multiply it perfectly, and survive. They took this crude-looking, incredibly heavy prototype down to Eastern Sound Studios in Toronto. The engineers there were highly skeptical of unproven gear, but they wired the Bryston into their console and connected it to their main studio monitors. Then, they pushed the volume. They drove the amplifier hard, demanding current levels that would have sent their usual equipment into thermal shutdown. The Bryston did not flinch. The bass from the monitors was tight, controlled, and physically impactful in the room. The high frequencies remained entirely clear, lacking the harsh clipping distortion that usually accompanied high-volume studio playback. More importantly, hour after hour, the heavy aluminum heat sinks on the back of the unit simply dispersed the heat into the room. The amplifier kept working. The engineers at Eastern Sound did not just praise the prototype. They refused to unbolt it from their rack. They bought it on the spot. Word spread rapidly through the close-knit Canadian pro audio and broadcast community. Soon, Phase 1 studios in Toronto ordered them, then local radio stations, then touring sound companies. The Canadian audio market had been waiting for a power source that treated audio amplification as a solved industrial equation. Every unit was built by hand in Peterborough. The process was slow, deliberate, and fiercely expensive. The transformers were wound with heavy copper. The chassis were bent from thick steel. The internal wiring was routed and tied with the rigid discipline of military hardware. To prove the design, the engineers in Peterborough instituted a testing protocol that bordered on mechanical abuse. Before any amplifier could be boxed and shipped, it was placed on a test bench, connected to an electrical load, and driven at maximum output for 100 consecutive hours. It was a burn-in process designed specifically to force weak components to fail on the factory floor, rather than in a studio control room. The logic was uncompromising. If a transistor was going to fail, let it burn out in Peterborough. By the mid-1970s, the Bryston name had become synonymous with indestructible power. If a recording engineer looked over at their equipment rack and saw the glowing green LEDs on the thick, black aluminum faceplate of a Bryston 4B, they knew the session would not end because of a thermal failure. The amplifier was a tool, like a heavy wrench, built to do a job flawlessly for decades. But a company cannot scale to a multi-million-dollar empire by only selling to a few dozen recording studios and broadcast stations. To survive and grow, The heavy iron of Peterborough had to leave the controlled environment of the studio rack. The studio monitor had found its driving force, but the consumer market in the living rooms of Ontario was a different beast altogether. To understand how a heavy block of industrial machinery became an object of intense desire for Canadian music listeners, one must look inside the metal chassis. The Bryston 4B was not merely a large box of wires. It was a physical manifestation of a specific engineering philosophy. At its core, the early Bryston 4B was a Class AB amplifier, an electronic design that splits the audio signal into positive and negative halves, handing them to different groups of components to balance high-power output with clean sound. But generating raw power is relatively easy. Generating pure, controlled power is mathematically difficult. The moving force inside any solid-state amplifier is the transistor, a semiconductor device that takes a small electrical audio signal and magnifies it into a much larger current capable of physically pushing a speaker cone. Because an audio signal alternates between positive and negative voltages, a Class AB design uses distinct sets of transistors to handle each half of the wave. The persistent problem in 1970s audio engineering was that positive and negative transistors are not perfectly symmetrical. They behave slightly differently under heavy loads. When the audio signal crossed the zero point from the positive transistors to the negative ones, it created a microscopic glitch known as crossover distortion. Chris Russell's breakthrough was a proprietary circuit design known as a quad-complementary topology. Instead of relying on unmatched parts, he designed a complex network that forced the positive and negative halves of the amplification stage to behave with perfect symmetry. In engineering terms, it smoothed the transition across the zero point, practically eliminating crossover distortion. But in physical, Canadian reality, this engineering translated into a startling acoustic experience. It meant that when a listener in an Ontario basement rec room played a heavy vinyl rock record through a demanding pair of PSB or Paradigm speakers, the kick drum did not just make a loud noise. The woofer, a large driver designed to reproduce low frequencies, was gripped with absolute electrical authority. It moved real air, stopped precisely when the recorded drum stopped, and recovered instantly. Because the quad-complementary circuit remained stable, the high-frequency crash of a cymbal playing at the exact same moment did not shatter into harsh, fatiguing noise. The amplifier simply did not run out of breath. Bryston paired this circuit with a dual mono design, an amplifier architecture where the left and right audio channels operate completely independently, each drawing from its own massive, heavy power transformer. If a recording featured an explosive synthesizer bass drop on the left channel, the left transformer handled the load. The right channel, perhaps playing a delicate acoustic guitar, remained completely unaffected because it was drawing from an entirely separate power reserve. This level of mechanical over-engineering yielded numbers that startled the industry. At a time when powerful amplifiers routinely struggled to maintain clean output, the Bryston 4B measured its total harmonic distortion, the unwanted change or harshness added to the sound by the amplifier itself, at less than 0.01%, even when driven to deafening volumes. This single metric altered the working lives of audio professionals. In elite recording studios in Montreal and Toronto, the Bryston 4B essentially removed the amplifier from the acoustic equation. An engineer mixing a dense rock track on a large analog mixing console no longer had to second-guess what they were hearing. If a vocal sounded harsh through the studio monitors, the engineer knew the harshness was on the master tape, not a byproduct of an overstressed amplifier. The playback was brutally, clinically honest. But recording studios are a finite market. A company cannot sustain a massive manufacturing plant in Peterborough solely by selling to the CBC and a few dozen recording facilities. The heavy iron had to cross over into the domestic market. The bridge between the professional studio and the Canadian living room was the hi-fi dealer, a specialized audio showroom where buyers could sit in treated spaces, audition equipment, and rely on the guidance of trusted local salespeople. In Toronto, The absolute epicenter of this retail culture was Bay Bloor Radio. When Bay Bloor Radio and other premium Canadian dealers began placing the Bryston 4B on their showroom floors in the late 1970s and early 1980s, it created a severe visual contrast. Consumers were accustomed to Japanese receivers featuring thin, stamped metal chassis, 50 glowing buttons, wooden side panels, and delicate tuning dials. The Bryston had a thick aluminum faceplate, 2 heavy rack-mount handles, a single power switch, and a glowing green LED. It was so heavy that placing it on a standard glass stereo rack would often shatter the shelf. Buyers usually had to leave it sitting directly on the carpeted floor. It was intimidating. Yet, when the dealer connected the 4B to a pair of large, inefficient speakers and turned up the volume, the demonstration ended all visual arguments. Audiophiles, listeners dedicated to achieving the highest possible fidelity in sound reproduction, realized that the exact same tool used to mix the record was now available to play it back in their homes. To make the transition into the domestic living room smoother, Bryston subtly refined the brutalist studio aesthetic. They offered the amplifiers with a silver anodized faceplate option, smoothed out the sharpest edges of the heat sinks, and eventually removed the industrial rack-mount handles for the consumer versions. They maintained the exact same military-grade internal circuitry, but dressed it just enough to sit comfortably in a high-end Canadian listening room. The strategy worked perfectly. A quiet consensus formed among stereo enthusiasts from Vancouver to Halifax. If you wanted to build a serious, permanent audio system, you bought Canadian speakers for their scientific accuracy, and you bought a Bryston amplifier to ensure those speakers never lacked power. This uncompromising marriage of studio power and domestic neutrality was about to scale into a multi-million-dollar industrial standard that defined the Canadian sound worldwide. Through the 1980s and into the late 1990s, the facility in Peterborough transformed. It was no longer just a boutique supplier for local Toronto recording studios, or a niche secret for Canadian broadcast engineers. It had become a full-scale industrial operation, a heavy manufacturing plant where the scent of warm solder mixed with the sharp metallic tang of machined aluminum. The Bryston factory floor was a working testament to domestic production. While other consumer electronics companies were beginning to look across the Pacific for cheaper labor, lighter chassis designs, and integrated circuits, Bryston doubled down on Canadian metal and discreet local engineering. Every amplifier was built by hand at individual workstations, not on a moving assembly line. Technicians hand-matched transistors, ensuring that the positive and negative halves of the quad-complementary circuit were perfectly balanced before they were ever soldered to a board. The 4B amplifier was no longer a single product. It had evolved into an enduring technological platform. Under the guidance of engineers like Stuart Taylor, the circuitry was continuously refined without ever abandoning the core philosophy of heavy power. This rigorous development led to the introduction of the 4B-ST model, and later the 4B-SST amplifiers that managed to lower the noise floor, the faint background hiss present in all electronic audio devices, to virtually undetectable levels. When a listener paused a CD player, a machine that reads a compact disc, and turns its digital data into music, the silence between tracks through a Bryston ST amplifier was absolute. There was no hum, no hiss, no electronic breathing. There was just black, empty space in the room, waiting for the music to return. This relentless pursuit of quiet, limitless power eventually caught the attention of the global film industry. In California, engineers at Lucasfilm were establishing the THX standard, a rigorous set of acoustic and electronic specifications designed to ensure that a movie soundtrack heard in a commercial theater or a premium home cinema sounded exactly as the director intended on the mixing stage. THX certification required amplifiers capable of delivering massive, sustained, and perfectly clean electrical current to multiple channels simultaneously, without distorting the dialogue or compressing the dynamic impact of an explosion. When Lucasfilm tested the Bryston amplifiers, They did not just pass the rigid specification, they became the reference standard. The heavy Canadian amplifiers were installed in Lucasfilm's own Skywalker sound mixing stages. Soon, commercial cinemas around the world, and eventually, ultra-high-end home theaters. Dedicated domestic rooms designed to replicate the commercial cinematic experience with surround sound and large projector screens were relying on the heavy metal from Ontario. The sheer scale of this success pushed Bryston into a unique global position. They were shipping heavy wooden crates filled with iron, copper, and aluminum to distributors in Europe, Asia, and across the United States. The domestic dealer network expanded rapidly. In high-end audio showrooms from Montreal to Vancouver, the Bryston rack became the physical and psychological anchor of the store. A stereo salesperson did not have to use flowery language to convince a buyer that the amplifier was well built. They simply asked the customer to try and lift it. The physical weight of the dual-power transformers proved the engineering reality before a single note of music was ever played. For Canadian audio manufacturers building large, power-hungry speakers, brands like Paradigm, Energy, and Mirage, Bryston was the ultimate enabler. A pair of large floor-standing speakers, tall, multi-driver wooden cabinets designed to reproduce the full frequency range of an orchestra or a rock band, required immense current to physically control their heavy bass drivers. In hi-fi shops across the country, dealers routinely paired these domestic speakers with Bryston power. It became the quintessential Canadian audio system, lab-measured acoustic speakers driven by studio-grade iron. By the late 1990s, Bryston had scaled from a regional pro audio solution into a defining pillar of the global high-end market. The factory in Peterborough was operating at peak capacity, turning raw materials into finished monuments of sound. But this massive international scale was entirely dependent on a single promise, a physical and financial guarantee that would soon become the most famous and the most dangerous commitment in the audio industry. In the domestic market, the Bryston amplifier became more than just a piece of electronics. It became a cultural fixture in specific Canadian spaces. In the wood-paneled basement rec rooms of suburban Toronto, or the expansive living rooms of cottages in the Muskokas and the Kawarthas, a specific audio ecosystem had taken root. Listeners in these spaces were buying speakers designed with the help of research labs in Ottawa, brands like Paradigm, PSB, and Energy. These speakers were highly accurate, but they demanded substantial, stable current to sound their best, especially when driving a large woofer to reproduce the deep bass of a CD or a vinyl record. A Bryston 4B, sitting on the floor or on a heavy lowboy cabinet, was the ultimate engine for this Canadian synergy. It was the accepted wisdom among audio enthusiasts. Buy the Canadian speakers for their scientific truth, and power them with the Canadian amplifier for its brute force control. But what truly elevated Bryston, from a respected manufacturer to an almost mythological status in the global audio community, was a policy decision made in 1990. Bryston officially introduced a fully transferable 20-year warranty on all of its analog audio products. This was not a marketing gimmick. It was a staggering financial liability that tied the survival of the Peterborough factory directly to the absolute unforgiving physical durability of every single component they soldered to a board. In the consumer electronics industry, a 20-year warranty is practically a death wish. Most companies build products with planned obsolescence in mind, expecting the unit to fail or become outdated in 3 to 5 years, forcing the consumer to buy the next model. By guaranteeing an amplifier for 2 decades, Bryston was betting the entire company on the assumption that their heavy iron would simply refuse to die. If the amplifiers failed in large numbers, the cost of return shipping, for boxes that routinely weighed over 50 pounds, combined with the cost of replacement parts and bench labor, would bankrupt the company within a few years. To honor a 20-year warranty, to honor 2-year warranty, a company cannot just build a good product today. It must warehouse the past. The facility in Peterborough had to maintain shelves of specific transistors, heat sinks, and switches for amplifiers designed in the 1980s and 1990s. This tied up immense amounts of capital in dead stock. The repair bench, a dedicated workspace where technicians troubleshoot and fix electronic circuits, became a living archive of the company's own history. A technician might spend the morning building a brand new amplifier, and the afternoon replacing a dried-out capacitor, an electronic component that stores and releases electrical charge, on a unit built during the 1980s. But the gamble worked because the engineering was real. Available reports and repair bench histories suggest that the failure rate of a Bryston power amplifier in its first 10 years of operation was remarkably low, often estimated at less than 0.1%. Because they had instituted that brutal 100-hour burn-in process at the factory, the weak transistors and faulty capacitors had already been weeded out. The amplifiers that reached the Canadian hi-fi dealers and the basement rec rooms were the survivors. This extreme durability created an entirely new phenomenon in the hi-fi market, the multi-generational amplifier. A listener could buy a Bryston 4B in 1992, use it every day to power a home theater system, and in 2010, sell it on the used market. The second owner would buy it with complete confidence, knowing there were still 2 years of factory warranty left. If a switch became noisy or a channel dropped out, they could simply pack it in a heavy box, ship it back to Peterborough, and a Canadian technician would place it on the repair bench, fix it, and send it back for free. The badge meant absolute trust. They had successfully proven that domestic manufacturing, premium pricing, and extreme mechanical reliability could scale into a highly profitable international business. But this exact strength, the creation of a permanent, indestructible object, was also a quiet, systemic trap. The problem was not the amplifier. The problem was the business model required to sustain it. If you build a machine that never breaks and you guarantee it for a generation, your best customers never need to buy another one. To keep the factory lights on, you must constantly find new customers in a market that is always demanding something newer, lighter, and more convenient. The amplifier was permanent. The market around it was not. But as the digital century dawned, the massive iron transformers inside the Peterborough factory began to feel the weight of a changing world. The shift did not begin with a catastrophic failure on the factory floor. Nor did it start with a sudden drop in audio quality. The long decline of the traditional heavy iron market began with a quiet, nearly invisible change in a high-end Montreal audio showroom. A hi-fi dealer who for 20 years had anchored his primary listening room with a Bryston 4B amplifier, quietly moved the heavy Canadian metal to a lower, less visible shelf. The amplifier still measured perfectly. It still controlled a large woofer with absolute electrical authority. But the customers walking into the stereo shop from St. Catherine Street were no longer asking for a separate preamp, a control stage that selects sources and prepares a signal before power amplification, and a heavy power amplifier to drive large passive wooden speakers. They were asking for convenience. A new generation of listeners wanted a streamer, a network audio device that receives music from online services or local files, that had all the necessary amplification built directly into its chassis. Or they wanted a soundbar to sit neatly under a flat-screen television, replacing 5 separate wooden speaker cabinets and a heavy AV processor, a home theater control unit that decodes surround formats and manages multiple channels. The existential threat to the Peterborough factory came in the form of a rapidly maturing technology, the Class D amplifier. For decades, Bryston had relied on Class AB architecture, which required massive toroidal transformers, electrical parts that change voltage and help supply massive current, and heavy external heat sinks to manage the continuous flow of electricity and the resulting high temperatures. This architecture was brilliant, but it was inescapably heavy and fiercely expensive. Class D amplification operated on an entirely different principle. Instead of continuously amplifying a signal, a Class D circuit acts like an incredibly fast digital switch, turning the power supply on and off millions of times a second to recreate the audio wave. Because the output devices are either fully on or fully off, they waste very little energy as heat. This meant a Class D amplifier module capable of producing hundreds of watts could be built the size of a deck of playing cards. It did not require a 50-pound copper transformer. It did not require sharp, heavy cast aluminum heat sinks. It weighed mere ounces, ran completely cool, and most importantly, it could be mass-produced in Asian factories for a fraction of the cost of a Canadian-built Class A/B amplifier. While the global market flooded with this lightweight, inexpensive power, the physical and economic reality in Ontario was becoming severely punishing. The cost of raw materials was climbing rapidly. The heavy copper wire required to wind Bryston's power supplies, the thick aerospace-grade aluminum needed for the chassis, and the specialized bipolar transistors were all subject to global supply chain pressures and inflation. Furthermore, domestic manufacturing required skilled Canadian labor. Bryston found itself in a systemic trap. They could not simply switch to cheap, lightweight switching power supplies or thin, stamped metal cases to save money. If they compromised the physical mass of the amplifier, they would compromise the thermal stability that allowed the circuit to survive. And if they compromised the thermal stability, they could no longer legally or financially uphold their famous 20-year warranty. The warranty locked them into building heavy iron, even as heavy iron became increasingly expensive to forge. Simultaneously, the Canadian retail landscape was fracturing. The traditional hi-fi dealer network, the trusted local stereo shops, where a salesperson could physically demonstrate the grip a Bryston amplifier had on a demanding speaker, was steadily shrinking. Big box retail, direct-to-consumer online sales, and online reviews were displacing the dedicated listening room. In the online era, an amplifier could not be lifted. It could only be read about. A consumer comparing specifications on a screen might see an imported Class D amplifier offering similar advertised wattage to a Bryston 4B for 1/5 the price. The screen could not communicate the difference in electrical current delivery, thermal mass, or a 20-year lifespan. It only communicated a spec sheet and a shopping cart button. Inside the Canadian home, the physical space dedicated to audio was also shrinking. The dedicated basement rec room with a sprawling, multi-tiered stereo rack was giving way to minimalist living spaces. Homeowners no longer wanted a massive block of metal sitting on their floor, glowing green and dominating the room. They wanted invisible audio. They wanted Bluetooth speakers and active streaming monitors, speakers that already had the DAC, a digital-to-analog converter that turns digital data into an analog audio signal, and the Class D amplifiers hidden inside the cabinet, eliminating the need for a separate rack of electronics entirely. By the mid-2000s, the great paradox of Bryston's success was fully exposed on their own repair benches. A listener who had purchased a 4BSST amplifier in 2005 still had 10 years left on their factory warranty. Their amplifier worked perfectly. Because it never broke, that loyal customer had absolutely no reason to buy a new power amplifier from Peterborough. The company had fulfilled its engineering promise so perfectly that it had essentially engineered its best, most dedicated customers out of the purchasing cycle. The Canadian listening room was changing, the cost of copper was rising, and the legendary amplifiers refused to die. The company realized that simply building the best power amplifier in the world was no longer enough to guarantee financial survival. To keep the factory running, the heavy iron had to find a new way to speak to a market that was rapidly moving into the cloud. Inside the Peterborough facility, the Russell family faced a grueling industrial dilemma. The pressure was not coming from a decline in the quality of their engineering. It was coming from the fundamental economics of manufacturing heavy objects in Ontario during the 21st century. The temptation to compromise was immense. Across the industry, other legendary Canadian and American hi-fi brands were quietly surrendering to global supply chains. The standard survival playbook for an aging audio company was to sell the brand to a massive international holding group. The new corporate owners would then take the respected badge, slap it onto a lightweight Class D amplifier designed in a foreign software lab, and manufacture it by the thousands in overseas factories. They would abandon the 20-year warranty, lower the price, and rely on the brand's vintage prestige to sell a fundamentally different, disposable product. Bryston refused to execute this playbook. The Russell brothers, Chris and Brian, alongside longtime Vice President James Tanner, remained fiercely committed to domestic assembly and the quad-complementary Class AB architecture. But staying true to the heavy iron was becoming financially punishing. The custom toroidal transformers required to make a Bryston 4B stable under heavy loads were incredibly expensive to source locally. A cheap, off-the-shelf switching power supply from an overseas vendor cost a fraction of the price, but it could not deliver the instantaneous, sustained electrical current that defined the Bryston sound. The heavy aluminum heat sinks, essential for dissipating the massive heat generated by the output transistors, were also climbing in price as global metal markets fluctuated. Furthermore, the physical logistics of the business were becoming a severe burden. Shipping a heavy 60-pound amplifier across the country to a hi-fi dealer in Vancouver, or putting it on a cargo ship to a distributor in Europe, ate heavily into the profit margins. To keep the company afloat without compromising the amplifiers, Bryston attempted to expand its ecosystem. In the 2000s, they poured research and development money into creating their own line of digital players, DACs, and eventually their own massive loudspeakers. The logic was sound. If the traditional hi-fi dealer was disappearing, Bryston needed to offer the consumer an entire, unbroken chain of Canadian audio, from the digital file directly to the ear. However, building premium passive loudspeakers, heavy, wood-veneered cabinets housing multiple drivers, in an era when the market was rapidly pivoting towards single-box wireless speakers, required immense capital. It forced the Peterborough factory to fight a war on two fronts, defending their amplifier legacy while trying to gain traction in a shrinking, highly competitive speaker market already dominated by established Canadian giants. Meanwhile, the legendary 20-year warranty continued to operate as a financial anchor. Every week, older amplifiers from the late 1990s and early 2000s arrived on the Peterborough repair bench. The technicians meticulously replaced worn capacitors, cleaned the internal contacts, tested the units, and shipped them back to the owners. It was an honorable, unbroken promise. It was also a continuous drain on resources that a modern, publicly traded electronics company would never have tolerated. By 2021, the physical and economic reality of maintaining an independent, family-owned manufacturing facility in Ontario had reached a breaking point. The founders were aging, the supply chain was tightening, and the required capital to compete in the modern streaming ecosystem was massive. The Russell family realized that to save the brand, they had to relinquish control. But they did not sell the company to an overseas conglomerate, and they did not allow the badge to become a diluted licensing tool. In a massive industry-shifting move, Bryston was sold to James Tanner and Colquhoun Audio, a manufacturing group led by Ian Colquhoun, the founder of Axiom Audio. This was not a bankruptcy. It was a strategic, defensive consolidation of Canadian audio manufacturing. Axiom Audio operated a massive, highly efficient production facility in Dwight, Ontario, complete with advanced woodworking machinery, anechoic test chambers, and established global shipping logistics. The transition meant the eventual closure of the original Peterborough factory, the birthplace of the heavy iron, the site of the legendary burn-in benches, and the physical heart of the brand for over half a century. The machinery, the inventory, and the repair archives were packed up and moved up the highway to the Dwight facility. Bryston survived by changing its ownership and its physical address, merging into a larger domestic group to achieve the economy of scale necessary to keep building things in Canada. But the final days of independent family control marked the end of an era. The market had shifted. The cost of copper doubled. The price of aluminum climbed. The shipping crates grew too heavy. The basement rec rooms shrank. The soundbars took the shelves. The wireless speakers replaced the towers. The independent stereo shops closed their doors. The era of massive iron was fading. The family could not fight the changing world alone. To save the amplifier, they had to let the company go. But the name did not vanish into a holding company's portfolio, and the 20-year promise did not break. The Peterborough factory eventually went quiet, but the Bryston name did not collapse into silence. The company did not become a hollow licensing brand stamped onto lightweight plastic streamers engineered overseas. It survived because it understood that to protect its legacy of heavy iron, it had to change its operational reality. Under the guidance of James Tanner and the Colquhoun Audio Group, production was moved north to Dwight, Ontario, nestled deeply in the Muskoka region. The new ownership structure was a masterclass in domestic survival. By integrating Bryston into a facility that already housed Axiom Audio, the brand gained immediate access to advanced, large-scale woodworking machinery for its expanding speaker lines, shared engineering resources, and a streamlined global shipping network. This consolidation created a powerful Canadian audio manufacturing cluster. The new facility in Dwight still smells of warm solder and freshly machined aluminum. Technicians are still sitting at individual workstations, hand-matching transistors and testing circuit boards. The heavy quad-complementary Class AB amplifiers are still being built by hand. By merging operations, they achieved the economy of scale necessary to absorb the rising costs of raw copper and aluminum, proving that domestic manufacturing could survive without surrendering to offshore mass production. But the true legacy of Bryston is not just the survival of the company. It is the physical survival of the objects they created over the last half-century. In the modern vintage audio market, a Peterborough-built amplifier is not treated as a piece of quaint nostalgia. On enthusiast platforms like Canuck Audio Mart or local Kijiji listings, an early generation 4B or a later 4B SST is treated as a highly liquid asset. They rarely stay listed for more than a few days. Audiophiles and younger listeners discovering physical media do not buy these massive blocks of metal simply because they look vintage. They buy them because the original engineering remains fundamentally relevant. The laws of acoustic physics have not changed since 1973. A large floor-standing speaker still requires immense sustained electrical current to properly control the movement of a heavy woofer. While modern, lightweight Class D amplifiers offer incredible convenience and high wattage on paper, many listeners find that when driving a difficult, low-impedance speaker load, nothing grips the driver with the same absolute, unyielding authority as a massive dual mono power supply backed by thick copper transformers. The old Canadian iron still solves a physical problem better than much of the modern digital landscape. This enduring relevance has sustained a vibrant, dedicated repair culture. On repair benches across Canada, technicians view a 30-year-old Bryston not as a broken appliance meant for the recycling bin, but as a serviceable, permanent machine. If a capacitor finally dries out after 3 decades of continuous heat generation, or a power switch becomes mechanically noisy, a technician can open the chassis, replace the discrete component, bias the circuit, and put the amplifier right back into service. The original design was entirely transparent. It was built to be maintained, fiercely rejecting the modern era of sealed, disposable electronics, where a single failed microchip renders an entire device useless. And perhaps the most remarkable footnote in the 2021 ownership transfer is what did not happen to that culture of repair. When legacy manufacturing companies change hands, the first casualty is usually the liability of the past. The new owners typically sever ties with older models to force customers into buying new inventory. But the Colquhoun Group accepted the financial weight of history. The legendary 20-year warranty remained completely intact and unbroken. An amplifier purchased in 2005 under the Russell family's leadership is still being honored today by the technicians working in Dwight. The promise was not attached to the Peterborough building. It was attached to the badge on the front panel. The story of Bryston is ultimately a testament to the extreme cost and the enduring value of mechanical integrity. It is the story of a Canadian company that treated audio amplification not as an artistic mystery, but as a solvable industrial equation. They built a machine so perfectly that it threatened their own business model, outlasting the retail showrooms where it was sold and the cultural era that created it. They watched the market shift from dedicated stereo rooms to home theaters, and from heavy physical media to invisible streaming networks, all while refusing to compromise the physical mass of their product. They proved that even in an industry addicted to planned obsolescence, a company can survive by building something permanent, provided they are willing to adapt the business structure around it. Somewhere in a Canadian basement, as the winter snow piles up against the small window of an Ontario suburb, a pair of old walnut speakers still stands beside a scratched, incredibly heavy black amplifier, the green LED glowing softly in the dark. The 20-year warranty long expired, but the iron inside still waiting for one more record to move the room. See you in the next one.